Hi and Assalamualaikum. We are from Group 8. I want to present about our project in Scenario 2, Coffee Temperature and Cooling Time. And this is our team members. We have 4 members in our group. Okay, for first person is Adana Shafika. Second is Turkistina Balkis. And third is Nur Nadira. And fourth is me, Siti Noraini.
Assalamualaikum, my name is Nur Nadira and today we are going to explore something familiar to all of us, which is how coffee cools over time. It might seem simple, but it actually involves important concept in heat transfer. In this project, we studied how the starting temperature affect how fast coffees cool down. We use simple linear regression to analyze the data. The data was adapted from a study by Dennis Romero and team, which explore how temperature and moisture affect coffee's thermal behavior. I will share the summary of our group meeting throughout the project. For our first meeting was held on the 10th of June 2025 through Google Meet. During this meeting, we focused on understanding the topic based on the given scenario. We also discussed the best possible solution and divide the task among our group members. For our second meeting, took place on the 12th of June 2025. In this session, we solved the problem using the appropriate formulas and recheck our solution. Then we divide the parts for our presentation video. Our final meeting was on the 1st of July 2025. We record our individual video parts, collected all the clips from group members, and compiled everything into one proper presentation video. That's the summary of our group project meeting. Assalamualaikum, my name is Nur Kristina Balkis binti Ibrahim. So for this task, I'm taking part for the Fila table. We have four facts that we're going to elaborate. So for the first one is the beginning temperature, which is the ambient temperature and liquid characteristic, all affect how quickly coffee cools down. And for the ideas, the higher the starting temperature, the longer it takes to cool. And for the learning issues, what factors have a major impact on coffee's cooling rate? And for the action, we decide to learn about heat transport concept and Newton's law of cooling. For the second, the goal is to analyze the cooling pattern using the basic linear regression. For the real-world physical, change can be predicted using statistical models. And for the linear issues, how is the modeling of the temperature change over time assisted by linear regression? For the action, we utilize internet resources such as Excel and any software that are relatable for the facts, and class notes to learn about the linear regression. For the third one, Newton's law of cooling states that heat lost to the surrounding air causes coffee to cool down. So, for the ideas, coffee cooling is a fine example of how physics and statistics can be applied on a daily basis. In what way does Newton's law mathematically validate the results of regression? So, we browse UTHM Learning Portal resources or journal articles about Newton's law of cooling. And for the last one, which is for the fourth, statistical analysis assists in the explanation of common thermal phenomena. So we understanding the physical process in daily life can be aided by data interpretation. For the asking, how can data analysis can be used in everyday situation? So for the plan, we decide to practice data analysis and interpretation with real-world examples, which is the coffee situation.
For problem background, coffee is usually served hot, but most people prefer to drink it once it's cooled to room temperature. The rate of cooling depends on a factor like the room temperature, the cup, and the coffee initial temperature. According to the Newton's law of cooling, Coffee cools faster when it's much hotter than the room and slower as it gets closer to the room temperature. This project explores how starting temperature affects cooling time using data from Teles Romero from 2000 and applies simple linear regression to model the process. As for the result, the cooling time for coffee starting from different initial temperature. As you can see in the table, the hotter the coffee, the longer it takes to cool to room temperature. From the table, we plot a graph of initial temperature against cooling time. The data shows a clear positive trend, so we use a simple linear regression to find the best fit line. The regression line is y equals to 0.365x minus 11.19. This means for every 1 Celsius increase in starting temperature, the cooling time increased by about 0.365 minutes. The slope shows the rate of cooling, which is higher temperature, cool more slowly. The intercept is not realistic since coffee doesn't start at 0 Celsius, but it's part of the mathematical model. In summary, the higher the temperature, the longer the cooling time. This supports Newton's law of cooling and match our expectation.
And now I want to talk about conclusion for our scenario. In conclusion, this project successful applies simple linear regressions to study the relationship between the initial temperature of coffee and the time it takes to cool room temperature. And by it showing a clear positive correlations where higher temperatures result in no longer cooling times. And apart from that, the regression equation y equal to 0.385x tolak 11.19 is a loss prediction of cooling time based on starting temperature. Although the intercept lacks real life meaning, the slope show that each 1 Celsius increase at about 0.38 minutes. And these findings support Newton's laws of cooling and demonstrate how statistical methods can help explain and predict real-world thermal behavior.